First and foremost, thanks everyone for taking the time out today to join the first webinar of the year. As you'll see, it's in partnership with Breathe Technologies, who we'll come on to very shortly in terms of an overview, etc. Before we get started, obviously, as people that have been familiar with webinars that I've done in the past, I'll be hosting this session today. Helping me along the way will be Phil, who's Director of Software Engineering at Breathe, Simon, who is Managing Director of Breathe, Nicola, who's the Marketing Director at Breathe. They'll be supporting me on the webinar. Phil's doing the demo. Simon's going to give us some insight into Breathe and the journey so far. Nicola is going to be looking after the team session and the PowerPoint, etc., etc. So yeah, so as we get started, the agenda for the session, we'll talk a bit about Breathe, give everyone a bit of context into the business, give everyone some context of the journey so far. So where has the Orquestr8 product come from? Why did Breathe Technology decide to invent such a product? I'll give you an eye-level overview of the product theoretically. Then we'll pass over to Phil, who'll give a look and feel demo of the system, have a look at what it can do, some of the insights into the product. Simon and then I'll just give a bit of an overview about our customers, specifically one example that's on the slide. I'll discuss some of the commercials around the product, talk about how to get started if it's something anyone's interested in. Then we'll do a Q&A at the end. There is a Q&A function available in this session, so if you've got a question as we're going, pop it in there and we'll come back to those at the end of the session. Obviously we may cover those as we go, but yeah, without further ado, let's jump in, let's get started, and firstly over to Simon to just give a bit of a synopsis of Breathe Technologies.
Thanks, Dan. Good afternoon, everybody. Thank you for joining. I'm not going to take too much time. Do you want to get on the meat of this webinar? So I'll give a quick overview of Breathe and who we are. So we are a system integrator delivering automation and software systems and software products into the logistics industry, and I've been doing so for around about 16 years. Formerly, we were called Conveyor Networks, but we rebranded as Breathe in 2021. So a new name, but an old company. As this slide there says, we have three main streams: software, warehouse automation, and support. Our software suite is in-house developed. It comprises of many modules covering most of the aspects of a WES or WCS system, including our Orquestr8 Pick optimization, which is what we're here about. Our automation ability, we're a hardware agnostic integrator, so we pick the most appropriate solution for our customer's problem. We're not tied to certain products or certain suppliers. We will supply what's best, what we think is best. We supply an end-to-end service from design to implementation, covering a wide range of technologies: conveyors, sortation systems, robotic sortation systems, cube storage, ASRS, boxing, bagging, labeling. Pretty much anything you can see in an automated warehouse, we can source and integrate and make work for you. And the last part on there is our support and maintenance services. We support all of our customers after go live, after market, with planned maintenance, preventive maintenance, 24-hour support hotline, upgrades, enhancements, audits, health checks, all the things that keep the system after implemented working and ticking along nicely. So that's us. A quick summary. Next slide, Nicola, please. Orquestr8 Pick Optimize, the journey. So through our experience of warehousing and automation, and through talking to a lot of our customers, we realise and know that picking in warehouses forms a huge part of the operational cost of a warehouse. We also know that it's typically a low-tech, very manual environment, unless customers go for a very high-end, high capex, highly automated system, which are tens of millions of pounds and can be, if not designed correctly, quite inflexible. So we were looking for a low capex, software-only, easy to implement system that would enhance and make benefits on the picking cost of an operational warehouse. So we had a look around. Adding to that, as the slide says, very recently the labour costs in the UK have changed dramatically with national insurance costs and minimum wage. They're rising. They're going to rise even more, we believe. Labour is scarce in some areas. There's more focus on sustainability for transport and packaging. And obviously, as always, pressure to increase the output with the same headcount. So we took all those things together and internally, with some very clever people, came up with this software that optimizes the manual picking in warehouses to address that end of the market where it's not high capex, high automation, and can fit to a range of warehouses. And I don't want to steal the thunder of the clever people in the room, so I will let Dan and Phil carry on explain about the product in more detail and how it works.
Thanks, Owen. So I think from my perspective, it's understanding the problem before we get to the solution, and the problem that we see really that Orquestr8 solves at a very sort of simple level is the manual picking bottleneck. So obviously pickers, depending on your size and your site and et cetera, pickers can be walking miles during shifts. Within that operation, orders can be split inefficiently. Cartons then obviously can be shipped suboptimally, so half empty at times, et cetera. My sort of within the WMS world as well. WMS systems are obviously fantastic, and the tier one systems out there can do some incredible things, as people on this call will testify. They're also told to do what you tell them to do as well. They don't necessarily dynamically optimize anything that's coming out of them. They're very good at what they do, and they've been configured by some incredibly smart people. However, that said, they don't then dynamically function and optimize the pick elements and the outputs that come out of it in the ways that Orquestr8 can do. And what we see actually is not people being slow in a warehouse or doing anything necessarily wrong. It's more so the losses happen between the decision-making elements. So in more manual warehouses, even in directed work environments, losses do happen between these steps. So again, that's the problem we're trying to solve here with this piece of software. Next. So I think as well, it's important to understand who's this software for. And in the short time I've been here, and obviously the years before I arrived, the main three people this software is targeted at are obviously, firstly, warehouse and operation leaders, so accountable for productivity. The world we're in at the moment is seeing an expectation of we need more with the same level of resources, or even sometimes more with less resourcing. And it's how we try and help operators and leaders within that environment to achieve that. Finance teams are obviously also very key because they're looking for ROI, they're looking for savings, they're looking for ways to spend either the same amount of money or less money. Inflation has been a challenge in recent years for our economy and other economies around the world. So, this tool is effectively trying to bust the inflation element of things. Not least, it's was about AI, different things, and everyone this that. They've got an AI driver, so I'm not sure that's going to make my golf swing any better. But as we can see, AI is everywhere, right? And what we tried to do here, and Phil's a big advocate of this, is use AI in moderation to solve actual problems and to apply it to the right scenarios. And obviously, Phil will touch on that in the demo. And just important to call out here, this piece of software isn't warehouse size dependent necessarily. It doesn't rely on having a fully automated site or a fully manual site. And it definitely doesn't rely on ripping out any existing systems and products, et cetera, et cetera. It's designed to be as flexible as possible depending on your, the nuances of your operation. So high level, before we get into the exciting bit and hand over to Phil to do the demo, what is Orquestr8? So effectively, it's an AI-powered picking orchestration level. So what does that mean? Importantly, this sits alongside your existing modern WMS, and it uses AI and it uses machine learning to optimize pick paths, to orchestrate batching, clustering, whatever you call it, reduced wasted walking around the warehouse. Especially in a lot of WMSs, serpentine walking patterns are the norm, and it's trying to reduce that, and then improve carton utilization or cartonization as we go. The important thing is this makes decisions in real time, and Phil will come onto it, but it is, you know, milliseconds, split seconds to get this optimization. There is no send it to us, we'll work with it and then send it back to you overnight or within a few hours, etc., etc. I think it's important to understand the benefits of the product. So the core benefits are obviously, as we discussed, the intelligent order clustering. You know, what are we picking together and where are they physically located in the warehouse to get the best optimal picks together in the shortest distance. And then once we know that clustering, how are we then physically going to pick it, right? That's the route optimization. So between those two things, we see roughly a 35 up to a 35% productivity uplift across the operation. Now, the bit that I find really exciting is all the stuff on the right-hand side of the slide, because yes, they're the core benefits we've just touched on, and that's like the bread and butter, you know, that's what it will do. However, depending on certain elements within your operation, there can be additional productivity uplift. So around volumetrics, hybrid picking, slotting, the machine learning element gives effectively, it's a feedback loop that comes back to us, and then we re-optimize the optimized work based on how you've executed those picks. And then there's obviously a management information dashboard within the system that can allow, you know, the operation to make decisions based on what they're seeing and what is happening within our platform and that information. And I think you'll agree that's you know, enough of me talking in terms of high level and hypotheticals, etc., etc. So what I'll do now is I'll hand over to Phil.
So just before I dive into the actual screen demos, just some basic details about the system. We are running on the Orquestr8 framework. So it's the same framework we use to build out our automation systems. We also use it to build out this Pick product. It's a modern microservices-based software. It's hosting agnostic, so we can run it on local machine. We can run it in the cloud as your AWS, etc., or we can run it in internal companies and cloud hosted, etc. It works by interfacing directly with the WMS, either mostly in a machine-to-machine sense, so that there's communication is between our system and the WMS to do the optimization piece. There's 4 API calls necessary to make the integration, so it's relatively light in terms of integration. And basically what we're doing is we're taking the picking workload from the WMS, the details of what items need to be picked from where in the warehouse for each particular order. And we are working with those orders to optimize and produce a pick list, send it back into the WMS so that the actual pick list can then be executed in the current process within the WMS, so with your handheld terminal or whatever existing way that you're doing your picking. So I'll start looking at some of the particular areas in the system. I'll give you a quick overview of how it would integrate with your particular warehouse and some of the benefits we get out of it. Probably one of the first places that we'll take a look at is the layout screen. Now, you can think of this layout as a digital twin of your warehouse. So basically anywhere in your warehouse where you've got storage, be that organized storage from in aisles and mezzanines, etc., or even if you have you know, less organized storage like runs of pallets, etc., in open space that you pick from, fast-moving goods from, etc. All those elements get recorded in this layout. The layout is accurate down to about 1 centimeter, and then we use a network of nodes that basically link all of the different shelves and pallets, etc., within the warehouse, and we can use that to find the fastest route between any 2 points in the warehouse and get the distance involved in moving between those 2 points. They're obviously essential for the optimization piece we do in understanding how much distance is involved in any particular movement in the warehouse, and we can use that to get a total distance for the pick list that we're optimizing, etc., to find the best route to power that choice of best route. So one of the things we'd be doing if setting up with you is we'd be, you know, taking whatever layout diagram we can find for your warehouse, or sometimes a DWG drawing or something similar, overlaying that with the information of your aisle names and shelf names, etc., to get this demo layout, or sorry, to get this layout complete as part of the system. One of the things that we would be doing with you, so the system takes over clustering for your picking purposes. So the tasks that come over to us are not yet clustered into their different types of picking. And we use a clustering engine within the system to actually identify, based on the orders that are coming over, we look at the dates, the types, any identifying features of those orders, and make a decision over how that order needs to be picked. So it's, for instance, is that an e-com order? Is it a single order, different to say a multi-line order? Is it a retail replenishment order? Are we picking into totes? Are we picking into cages, etc.? All of those decisions can be made using these clustering rules. One of the advantages of these clustering rules over the kind of standard rules that you see in WMS systems is that this is a no-code system. You can come in here as a user or as an administrative user, and you can make changes to these very quickly. You can test them, you can save them, and you can start running with them immediately. We can also have multiple rule sets available in the system. So you could have 2 rule sets, maybe if you're running a different set of rules for daytime picking to nighttime picking, or maybe midweek picking to weekend picking. Or even just a special rule set that comes into play during peak because of the increased number of people and the increased workload. That kind of thing you can do very easily with this system without getting someone in modifying the code of your WMS. So it's quite a useful area of the system. What it helps us do is take those workloads that are coming in, identify the type of picking that we're going to be doing, and link that to a specific physical type of picking. So, okay, this order is going to be an e-com single, and we're going to pick it in a bathtub with another 100 similar single orders, etc. All that is specified through this clustering piece. Once we've run that clustering rule set, what you'll get is a set of the individual picking profiles that are available from that clustering rule, and it comes into this dashboard. So currently the system can operate in 2 different ways when we're looking at how to release work. We can do a wave response model where which we typically use for retail orders, where a large collection of orders are allocated over to the system in a wave, and in response to that wave, the system will generate all the optimized pick lists necessary to complete all the picking in that wave, and then that gets sent back immediately to the WMS system. So there's no manual intervention on the breathe side, or no operator intervention on the breathe side. That data comes over, gets optimized, and gets returned as a set of pick lists back to the WMS, so that the WMS can then execute it. The other way we can run the system, which we more typically use for e-com pick lists, is that we build up a pool of orders in the breathe side. So as an order arrives in the WMS and is allocated a picking location in the warehouse, that order is then transferred over to us via the API, and it sits in our pool and builds up ready to the point that your operatives are ready to release work. So you've now got a new shift started, you've got maybe 4 or 5 pickers working in a particular zone, and you want to start releasing new work for those pickers. You can come in here and you can see the order well, you can see how many orders are sitting there, how many lines that is, how many units are involved in completing those orders. An estimate of how many pick lists that would be necessary to actually complete out those orders. And you can release work either at the profile level, so you could just start releasing all your work for, in this case, e-com multi. Another thing you can do, the system supports or understands the priority of orders. So when trying to use the system, we want to get a balance of the optimization piece, but also with your operational requirements. So we're not just saying these are the best pick lists, go away and work on it this way. We are still always trying to keep an eye on what is necessary for the operational requirements of the warehouse. So we can concentrate on things like the ship by date of orders, any particular priorities coming over from the WMS system that identify orders that need to be processed earlier. Maybe you've got next day deliveries where the pickup's at 4 o'clock in the afternoon that you need to get them processed as soon as possible. Maybe you've got VIP orders. You know, we see orders for influencers and review sites, etc., requiring to be processed as soon as possible so that they go out with a sort of VIP service. So things like that, we can take into account all of that when releasing the work from the system to make sure that the operation requirements are met, as well as optimizing the pick lists. When those pick lists are released, the two primary benefits that I think Dan referred to earlier are all about reducing the distance walked. So the whole sort of initial benefit of this system is trying to reduce the amount of distance that your operatives walk when completing a pick list. The two key ways to do that are through what we call spatial batching, which is choosing the right orders to go together. And then the other way we do that is through optimizing the pick walk for each pick list. Now, here in the demo system, we have this particular screen to try and make it easier to understand how the spatial batching piece works and where the benefits come from. So we've got about, I think it's 200 orders in this demo system that we use for this batching piece. And what we've done is we've generated pick lists in two different ways. A FIFO approach, which is first in, first out. So basically, your standard WMS, when it's looking to release orders onto a pick list, firstly, it'll look at things like the ship by date and the priority, etc. But once it's gone through the more obvious priorities and ship by date, etc., it's going to put those orders onto a list just based on the age of the order. So the first 10 orders that came in will go together onto a pick list, and then the next 10 orders that came in will go on the next pick list, and so on. And that's what we're looking at here with these FIFO lists. So we generated these lists on the side here, 9 lists generated by the age of the order. And then on the other side here, we've got 9 lists that are generated based on our spatial batching algorithm. So looking at which orders go well together to reduce the overall walking that you'd be doing to complete those pick lists. Now, we can look at these visually on the layout here. So what we've got is the layout of all the shelves, etc., in the warehouse, and you can see a lot of coloured dots on here. Now, those coloured dots represent the picks that are necessary to complete a particular pick list. Now, you can see at the moment, this is looking quite messy, quite chaotic. And if I look at an individual pick list in this set that have been generated FIFO, so basically by the age of order, we're pretty much covering the complete zone to complete that pick list. So we're walking through every aisle from the beginning of the warehouse to the end of the warehouse to actually complete this particular pick list. Those orders covering the whole of the warehouse, and similar in some of the other ones, you can see again that there's quite a lot of spread, there's quite a lot of aisles that have to be visited to complete that pick list. If I look at our spatially batched ones, if I look at all of them to start with, what you should be seeing here is almost like a rainbow spread, a much more ordered collection of colours, which indicates, helps us understand that what we can see here is when we've switched to our spatial batching, each of these pick lists is now covering a much tighter area within the warehouse, in this case only 2 or 3 aisles, instead of crossing the whole warehouse. And that sort of focus on only completing the area of the warehouse that's absolutely necessary for that pick list is where a lot of the initial savings come from. So you can see that in total, when following the 9 pick lists in the FIFO batching, the first in, first out batching, we're covering just over 6 kilometers to complete that set of 9 pick lists. So it's the same collection of orders, same number of pick lists, but over 6 kilometers. In the spatially batched equivalent, again, the same set of orders, again, 9 pick lists, but overall distance required to complete that is now only 3.6 kilometers. So, you've saved over 2.5 kilometers from that, just reorganizing the way orders are put onto the pick list. And it's probably over 40% saving in distance just from choosing the right orders to go together onto the pick list. And that's one of our primary benefits, is this spatial batching. On average, across a retail and e-com mix, we see somewhere between 50 to 55% savings in distances from that overall. The second bit I touched on was the routing element. So once we've chosen the right orders to go together onto a pick list, we then look at all of the shelves that need to be visited for that pick list and find the right sequence, the best possible sequence to visit all of those shelves. Now, usually in a WMS system, they'll follow a serpentine approach where you're literally sort of traveling up one aisle and then down the next aisle and then up the next and following in a serpentine pattern. And there's nothing necessarily wrong with that. It's a quick and easy way to generate a route from a list of locations that's visited. But it's not the fastest way to get through the warehouse. It's not the shortest way to get through the warehouse. So in this example here, we've got, you can see for this pick list, all the red squares are shelves that need to be visited for the pick list. There's a green square to indicate where the trolley would be, an empty trolley would be picked up from, and this red square at the bottom is where the full trolley would be dropped off from. So you can see the route, the serpentine route, which the WMS would have created, is going to take us as far away as possible into the warehouse. It's going to drop us down in, and then it's going to start us picking the pick list following the route upwards. Then we're going to drop down into the next aisle. Then we're going to come across the bottom, and we're going to come up into this aisle, collecting as we go, dropping back out before finally visiting the last pick location and coming down and completing the route. Now, it looks relatively reasonable. You know, there's nothing about that that looks like you're wasting a lot of distance in completing that movement. That route is about 436 meters in that serpentine sequence. If we now look at the optimized route produced by the Braid system, we've saved over 100 meters and without doing anything particularly complicated, just by changing the sequence that we actually start visiting those locations. So we come in across the top, we drop down to pick up the first location here, move across, pick up us on our way down. Now, we'll then run across the bottom, pick up these two while we're down at the bottom before making the final loop up to the top, and then drop down, completing those picks and closing out the pick list. Now, what this system is basically doing here is trying to avoid the back and two motion and the vertical motion through the aisles. And just by making that change in the sequence, there's over 100 meters saving, which again, I think is about 27% of a distance saving. Now, this is probably a nice, simple example. Obviously, the pick list can get a lot more complicated than this, and the routes that save can get a lot more complicated than this. But this example is sort of easy for the human mind to understand where the savings are coming from. These savings stack on top of the spatial savings. So when we were looking at that spatial savings previously, that was over 40% saving from choosing the right orders. And then on top of that 40% saving, there is another 30% saving again in the way that we've now optimized this loop. So this is how the two main distance-based savings in the system stack together. On top of that, there's a lot of elements in the system that focus on trying to make reduce the overall number of pick lists that you have to complete to get your orders picked. And some of the ways we do that is we look at volumetrics. So we look at the right choice of picking container for orders. So one of the things we might do in e-com, say, is we might look at the size of the order volumetrically, and we can either work with multiple different sizes of container to try and get more orders on a pick list. So we might have large orders go on like 8 containers on a trolley, might have medium that go on 16, and we might have small that go on 32 containers in a trolley. One of our customers is actually running up to 64 e-com orders on a single trolley. And the other way we can do it is through something called dynamic dividers, where rather than having different tote sizes, you have the same size tote, but that the user is guided to place dividers in the tote so that large orders can take the full size of the tote, but then you can split the the tote down using those dividers up to 8 ways. So you might now have 8 orders in a tote. And the advantage of that is that rather than taking out 8 pick lists to complete a collection of orders, you can suddenly complete those orders in just 2 pick lists because you are able to stack so many more orders in the same pick list. Things like that help to reduce the overall number of pick lists, and it just means that you're getting really dense orders, the most number of units possible per pick list, and that starts to give sort of secondary benefits in productivity. The other thing that we can do with that volumetrics piece is if you're dispatching, picking directly into dispatch containers like cardboard containers going out to retail stores, etc., then we will also optimize to reduce the number of cardboard containers that are going out, and those are again additional benefits that the system can drive in direct savings against the cost of shipping and against the cost of container use. And usually, you know, we see all those as benefits on top of the ROI that we've calculated. We'd usually calculate the ROI just on the distance saving. So anything that comes from the productivity benefits of reducing the pick list or from the savings, direct savings that are coming from those shipping cartons and shipping costs, they tend to be like sort of additional benefits. We've got one customer running at the moment that they get back nearly 60% of their monthly cost from those direct benefits before looking at the benefits they're getting from the optimization. So, you know, they can have quite a significant effect as well as the distance saving. I think that was probably all the bits I wanted to run through in this demo. Obviously, if you're interested in understanding more about the software, you can reach out to us and arrange a more in-depth overview of the system, but I think that was just a quick one to get through some of the main points.
Thanks, Phil. That was yeah, it was a good, as I say, good insight into the main features of the system. There's quite a few questions come in the chat, which we'll try and answer at the end. But I think it's important just to say at this point, obviously the system is live across several customers. As you'll see on this slide, GXO is one of them. So just Simon, if you could just, this was a little bit before my time. So Simon, if you could just give a bit of context on what this customer journey was really, and what they've seen out of the system.
Phil, my best place to talk about that. They were our pilot customer. So we did they were the first site that went live, and we worked very closely with them to develop the product and improve the product. As the quote there says, they're very happy with it. They have quoted themselves up to 35% productivity improvement for it. They are using it in a largely, is it e-com and retail pick? Maybe Phil, you can talk more about it. Actually, you know more detail about it than I do.
Yeah, certainly. They run a combination of different picking types. We do everything from pallet picking, case picking for retail, individual items for retail, and then finally a full e-com operation as well. So they're running the full range of different picking types there. Some pick into pallets, some mainly pick into trolleys, and yeah, they're sort of slightly different benefits for each of the different types, but overall a productivity uplift of 35%.
Thanks, Phil. So I think at this point, it's certainly since I've joined, I suppose, speaking to different people about the software, etc., there's a few myths or frequently asked questions, however you want to put it, that have just cropped up within my conversations, really. And one is, you know, the first one is this is going to be expensive because it saves a load of money. So usually with this sort of software, there's, you know, a saving sharing goes on to a you know, higher degree than that you know the customers would expect. But I think from our perspective, the key thing really that we wanted to try is that demolishing of barriers to entry. So there are no upfront capex slides from our cost to get the system going. It's subscription SaaS based, and it's relatively fast deployment. So what we see from signing of contracts to going live / seeing benefit is around 12 weeks. So it's not, you know, it doesn't take years and years and years to get this going, and more importantly, seeing the benefit of the product. The second myth is usually WMS related, that something like this would have to require modifications to the WMS, etc. As I've said numerous times, and I think as Phil demonstrated quite neatly there, it does sit directly alongside your WMS. And then the third thing, as I've talked to a lot of IT people about, is it's gonna take a lot of my time. It's gonna be a pain in the ass to get going, etc., etc. So it's important to just say it's light touch, fairly standard API creation. There's actually 4, which we'll come on to very shortly, and that maintains that 12-week onboarding process. So from an integration perspective, I think it's important to stress it's the four APIs. So we need the picks into our system. We need to give you the optimized picks back into the WMS system. The third API is for a feedback loop. So once you've executed those optimized pick lists, we want that data back so we can re-optimize them in the future. And then the fourth one is cancel pick effectively, so you can cancel stuff within the system. But in terms of who handles what, on our side, we handle the optimization as you'd expect. We could host it for you. We'll configure it with you to start with the setup, and then obviously fine tune it as we go along. And then with the ongoing support package, as Simon mentioned at the very outset. And then on the customer side, you give us the data access and the approvals. You'll build the APIs. You'll manage the security and governance checks. And then obviously, once it's all live, there should be minimal interaction from an IT perspective, WMS perspective on the customer side. So commercially then, how does it work? So in order to generate your site-specific, business-specific ROI calculation, there's 7 data points. And after this call, we'll send around a link to to fill in a form if you'd like to generate an ROI calculation for a site you've worked on or a site you're working with, et cetera, et cetera. We can do that for you, and it requires 7 data points. From there, there's a base cost for the product, which is a fixed monthly cost. From there, you then pick what support package you want. So is that bronze, silver, or gold? Based on effectively how mature or immature your WMS team are, or how mature your operation is, et cetera, et cetera. Some people need sort of white glove hand-holding, taking through that, and real sort of intense support. Other people are just like, what, we're pretty good at what we do. We don't need that. So somewhere in the middle usually works. And then you decide how you want to host it. Do you want us to host it? Do you want to host it yourselves on-prem? Do you want maybe your WMS partner to host it, for example? And the last thing to do is obviously then sign the contract once you've decided that you want to go with it. But it is a pretty pain-free process to get going on the journey. And yeah, that realistically 4 minutes before the question and answer time should bring us nicely onto Q&A. We've had quite a few in the chat, which I think, to be fair, looking at them, are pretty Phil related by the looks of it. Some semi-technical questions. So what we'll do is I'll just start at the bottom and work our way up, if that's okay, and then throw over to Phil and Simon to chirp in on the responses. First one is the technology suitable to integrate with Manhattan Active as a WMS? For me personally, just to answer this, so it is live, as I say, several customers. Those customers run beyond a dispatcher as a WMS. We've talked with our WMS partners that we currently work with. There's no reason why it won't integrate with BYWMS, so the artist formerly known as Discrete. From a Manhattan perspective, again, speaking to our partners, it's an API-driven, enabled WMS. There is no reason why it should not connect to that. API-related question, Phil, probably for you. Is there a plan to move away from loosely coupled REST APIs to a no-coupled fact-based integration?
It's not something we've looked at so far. Integration-wise, we do all of the more standard stuff. We do message queue integrations. We can do flat flower integrations and REST API, which is our standard approach. But we've not looked at a non-coupled integration approach. Again, if it's something that would be necessary for a project or considered to add value, then it's definitely something we can look into. Through the automation side of our business, we offer a very flexible approach to integration, getting data in and out of the system. It's one of our key features key benefits in the way that we can do integration projects. So yeah, we'd be more than capable of looking at different ways of
okay, cool. next question. Will it handle order amendments from source systems during active picking? For instance, if Blue Yonder picking is underway and the order updated via SAP ECC API is amended by users mid-process?
Good question. And I think there's a similar one higher up. So it somewhat depends on the way the system is actually implemented. So the most popular way we're implementing at the moment is in a kind of machine-to-machine approach where we do the optimization, but it's a relatively light touch. So we'll optimize the pick list, we'll send them back into the WMS, and crucially, they are then executed within the WMS. To be able to enable that sort of real-time resequencing, or suddenly the orders change, can we add a new pick into the list, etc. There's two ways to do that. The most effective way is using our native picking application. So we have a native picking application, an Android application that can run on a handheld terminal, your standard Android handheld terminals. If you're running that way of using the system, so doing all the actual pick execution to our side, then yes, we can do that in-flight update. If you're running through the, as I said, the more M2M approach, where the picking is still being executed in the WMS side, then it becomes a bit more difficult to update those lists. We've done integrations in the past where, while the pick list has still not been started, so we've sent a batch of pick lists back, and the pick list still hasn't been assigned to picker, we can basically send a notification through API to WMS that there is now a change to that pick list. But once the pickers actually started picking it then becomes a little bit more difficult to update those, to try and get those WMS systems to change the route and the pick task once it's actually in flight. So short answer is yes, doable if you're using our picking execution application, and to a lesser extent doable if you're using your own internal WMS picking execution, but with a bit more limitations on how last minute you can actually make the change.
Yes, well, question here around a few APIs to set up and get running. Will it feed back LMS data, so labour management system data? Obviously, I know we partner with, or are talking about partnering with, a certain labour management company who have a product. So I imagine that's on the roadmap, but Phil?
Yeah, so again, I suppose in a similar way to the previous, if we are completing the picking execution itself, then we generate all the data, the timings involved, and can present that data back to an LMS. But again, in the sort of the lighter weight way that we implement, the execution retains in the WMS, so it's your own WMS that will be in position to track that LMS data. And again, we've worked with partners in the past that can then extract all that data and provide the sort of management oversight of how well your teams are running. So you've got the two options there. You can either extract it from the WMS after executing, or if you're using our handheld software, then we can provide that data.
Thanks. Question, I think we've kind of touched on this one about interjecting tasks into the existing work lists, etc., etc. So, that I think we've touched on that one. A topic that's come up several times in conversation with customers and different things. Does the algorithm consider in-flight replens? Now, replens is obviously a hot topic in Breathe HQ at the moment around what we can do and help around that. So, Phil, some thoughts on replens?
So at the moment, we work with a pre-allocated pick task. So in other words, the WMS has already decided that this particular picking task can be completed from this bin at this location. We are in the process of developing an optimized replenishment tool, and looking to try and basically optimize the replen and put away at the same time as optimize picking. I think that would be sort of leaning more towards that type of scenario where we'd have then the visibility of when the replens are being completed, so that we could redirect to a more suitable location. so that if we suddenly find that we've now replenished stock in a location that's closer to the route that we're already working on, then we can dynamically reassign. And again, it touches back onto that sort of previous point about dynamic changes or in-flight changes that would require using our HHT software. But yes, it's certainly something that we would like to be doing, and we're in the process of working with a partner to actually look at that dynamic replan optimization as a sort of mirror image of what we did with the pick optimization.
Makes sense. Direct question here. We use Manhattan Active to fulfill store orders. We run waves in the morning and it creates picking tasks. Once these tasks are created in Manhattan, we cannot edit them. Is this tool suitable for our organization?
So if the picking tasks being created, not editable, shouldn't necessarily be a problem. Once they were created, those picking tasks will be sent over to us, and then we would optimize and return it. The crucial element is whether you can then run an updated pick list. So those tasks would come over to us, we would do the optimization, and we would return a pick list, the optimized pick list. The key point with those pick lists is that to get the most benefit out of our optimized pick list, you need to be able to visit shelves in the sequence as specified in that pick list. So as long as there's a way to get the WMS to follow a specific sequence and not the sort of baked in serpentine sequence, then you'd then be able to get the benefit out of the optimized pick lists.
Thank you. Next question. The problem with WMS and WCS is they generally handle commands and optimize a process or department. The need is to orchestrate across processes, workflow, and waving in order to synchronize pick, optimize pick density, space, order hospital volume. This is often done manually and not resilient. Is this where Orquestr8 comes in?
At a basic level, the system sort of takes over once those wells have been built up. So that sort of the process before that to try and get the operation to hold back picking for as late as possible to build up the largest order well to get the best optimization is in the systems we're using at the moment is still being run manually by the operations team, by the control room team. Is it something we can help with? Probably. Through the dashboards, etc., that we have it, we can certainly make it visible that you've got to an optimal level that before you wave, so you've got enough orders in the system to start producing really good optimized picking. And in fact, I think one of the next features that's going live in the system is the ability to preview a wave of pick lists, so you can actually, before releasing the pick list back to the WMS to be picked, you can see the quality of each pick list. So we rate each pick list in terms of the pick density and the number of orders being actually covered by that pick list. So you can almost, if you say you want 20 pick lists, you can get the next 20 pick lists, but then you can actually see, right, the first 12 of them are actually high quality pick lists. The next 6 are, say, medium quality pick lists, and the last 2 you probably really don't want to pick because you're wasting your labor. So that starts to give you that ability to understand the quality of the pool that you've built, how you've saved the work. The wider piece, helping to control how they build that work up, hold that work back, is not something we directly do at the moment. But again, it would be a good platform, a good place to start working on giving them tools that would help them to understand whether they are building that work up properly before releasing.
Okay, that makes sense. Next question. Using your Android app for picking and bypassing the standard terminals, would that be a license violation for systems like Dispatcher, BY Dispatcher? I think just personally on that question, Dispatcher specifically, obviously, we run it across three sites that use Dispatcher at the moment, and that our picking app isn't required because Dispatcher is obviously a modern, flexible WMS that we just bolt very, I suppose, light touch on the side to do that. Would it be a violation for other WMSs that we needed to use our app because the WMS wasn't feature rich enough to accept us? I don't know. I suppose that's a dependent on each WMS specifically, isn't it, Phil? I don't know whether you've ever come across that before.
Yeah, certainly we don't come across it before, but it is a good question. So obviously using our app, then you would need less user licenses for the picking side of the WMS. So potentially there might be something in the individual commercial contracts that sort of prevents that, as it views it as a sort of circumnavigation. So we'd be unable to comment on the impact on a specific system, but certainly if there's one in mind, then we can maybe look into it offline.
Thanks. And then last question I've got so far is, we run a customized WMS with a rules engine that seems similar to what we've spoken about. It would be interesting to see if you guys could offer a review of our current setup, suggest potential improvements without having the full-blown integration. If we gave you a data set, a week's worth of orders and picks, for example, and a warehouse layer, could you send back suggestions? I think that's something we've done obviously previously with the simulations, etc., etc. Question about AI, Phil. Phil, you can go for this one, or Simon, or someone. Is this generative AI? If so, what are the chances of hallucinations?
So not generative AI. It's another form of AI known as nature-inspired algorithms. So they are algorithms that reach human or better than human level of intelligence when solving key problems. So there's no risk of hallucinations. It's a different type of AI than the kind of generative stuff you see in ChatGPT.
Yeah, thank you all for taking the time out to join the session. Thank you to the guys, Phil, Simon, and Nicola, for supporting me on this. And